Well, hello everyone. Thank you for having me. Um, Today I'm gonna talk about this topic that in our industry it basically goes under multiple names. Sometimes we call it software supply chain security. Sometimes we call it end-to-end software security. Um, the overall idea of securing your software delivery from dev to production is basically how do you implement a set of processes and framework that exists today that allows you to make sure that your software that makes it to production is as free of vulnerabilities as possible. And so hence the title of my presentation, which is Secure Software Delivery from Dev to Production. My name is Abdel. I'm a cloud developer advocate at Google. I've been at the company for almost 10 years. I co-host a podcast called the Kubernetes Podcast by Google. And that's my Twitter in case you want to reach out to me if you have any questions about this topic. And before I get going, let me start with like explaining why it matters, why software supply chain security matters, and why people care about it. Well, if you are a software engineer, you're probably familiar with this picture. The way you get software from your developer environment into production typically starts with some sort of source code that you put into a build system with a bunch of dependencies most of people just pull from the internet. And then you put these things together, you produce a package, and then you put this package in production. If you want to be really honest with ourselves, I think that the dependency part should be slightly bigger than your source code part, because you're probably pulling and using more dependencies and relying on other people's work than you're actually writing your own code. I mean, there is more basically code coming from dependencies than code written by you or by your organization in general. And also because it's important because no one has time to just reinvent the wheel and recreate build systems and things of that nature, right? So what most people are not really aware of probably is that even your dependencies kind of follow the same notion, the same path, the same processes. They are also starting with some source code, which probably they all pull some dependencies from the internet, and then they just package it. It's just that the package that they produce is not a binary or not an image that you run in production. It's a library or a dependency, right? What have happened over the last few years, I mean, in the last 20 years as an industry, we have gotten very good at trying to secure our production systems, keep the bad people out. But what we haven't really done very good job with was making sure that that vulnerabilities and security problems doesn't happen early in the development lifecycle of a software. And that prompted bad actors to try to actually hack you or hack us early in the development cycle by trying to inject vulnerabilities in common open source tools or common binaries that people use. I'm going to give a few examples, but just numbers that you can see on the screen are actually quite frightening. A 650% surge in the OSS supply chain attacks. That's basically people intentionally injecting backdoors and vulnerabilities into open source packages that people use. 81% of commercial code-based code have some sort of OSS or open source vulnerabilities. And by 2025, it is estimated by Gartner that 45% of organizations will experience an attack which is caused by software supply chain. You probably have heard of Log4j or maybe SolarWinds. SolarWinds is a company that produces software that was used by, among other things, the Continental Pipeline in the US, which supplies the East Coast with oil and gas and created a lot of problems and people freaked out. I think one example that was very close to home, I live in Sweden. We have a very popular supermarket chain called Coop. So Coop has something like 500 stores all over the country. They rely on a third-party IT company to manage their self-checkout booths. That company also relies on a third-party software by a company called Kaseya. So Kaseya got attacked. They got a vulnerability into their software. They injected into their company's systems, or they supplied the software to their companies or their customers. One of their customers is this IT company managing something on behalf of Coop, which then supplied the patch to production, and Coop ended up with a backdoor sitting in their system for almost 2 months. I'm using this illustration as a way to say that like the problem with also software supply chain security type attacks is that they could start small and impact one company that produces commercial software that could be inherited by other companies. And that's because your software supply chain system. By the way, just to explain what software supply chain means, essentially, it basically software supply chain means the set of steps that we use to get software from where it's produced to where it's consumed. So similar to supply chain for food, for example. And security essentially means how do we secure this supply chain, right? And I think it's just a fancy term to say CI/CD, essentially. So your source code could be, intentionally or unintentionally impacted. Somebody could compromise your source control. Somebody could compromise your CI pipeline or your CD pipeline, could compromise your dependencies, etc. So there are a bunch of ways you could actually be compromised. And so what happened over the last few years is that some people started, some very intelligent people started having this set of like practices and movements. One of them is called shift left. So shift left really means two things. So shift left as a concept is coming from DevOps. In the DevOps world, the whole idea of shift left is how can you shift the responsibilities of production toward development or toward developers. In security space, shift left essentially means how do you make developers aware of what they're doing, and how do you establish trust early in the software lifecycle? How do you make sure that the people who are supplying software are those who say or claim they are? How do you make sure that your software have been built in systems that you trust? In a world where cloud is big and where everybody relies on third-party CI systems and without particularly, I'm not bad-mouthing, but just an example is GitHub Actions. Everybody's using them, but like, how do you make sure that the worker node in which your build is executed is actually the one that GitHub owns? What if GitHub gets hacked and somebody injects build systems, or somebody injects some vulnerabilities into the build system that just leaks source code or something like that? So these are all set of problems that we're trying to solve with shift left by basically making sure that we can establish trust through the entire chain all the way until production. Zero trust is also another term used for software supply chain security. It basically means trust but verify, and essentially it means how do you make sure you have mechanisms in place that you can use to trust and to sign and verify software, and make sure that the software is coming from credible sources. A bunch of things have happened in this space of software supply chain security. Maybe one that you have heard before is this project called Sigstore. So Sigstore is essentially a group effort of multiple companies trying to solve the supply chain problems. They produce softwares and frameworks that are trying to solve three different problems. So one of them is the trust establishment and verification part we talked about. The second set of problems is transparency through monitoring, and then the third problem is best practices, security best practices. So Sigstore is a project by multiple companies, multiple organizations. It's under the one of them is the OpenSSF, the Open Software Security Foundation, which is a sub-organization under the Linux Foundation, right? And one other thing that Sigstore comes up with is this framework called Salsa. So salsa.dev, which stands for Security Levels of Software Architects. It's written SLSA, but it's pronounced Salsa. So Salsa, what it is, essentially, it is a set of practices that your build system, so your source control system, your build system, and the way you handle your supply chain have to meet the requirements to be able to say it's compliant with level 1, level 2, level 3, level 4. I'm not going to bore you with the details, but these are some of the requirements for Salsa level 1, 2, 3, 4. Let's take Salsa level 3, which I think, in my opinion, is more probably what most people will be able to achieve effectively. So that we have things like version controlled code, scripted build systems, ephemeral build system, isolated build systems, etc., etc. There is a new version of Salsa called Salsa version 1.0, which focuses mainly on the build part. But as you can see, these are all kind of best practices and the requirements. There is like, how do you implement them is really up to you and up to your build, like the way your company work. As long as you are meeting those requirements, elements, then you can confidently say, yeah, my build system and the way I produce software, my software supply chain meets, one of these levels. Sigstore produces also software. I'm going to do a demo with Cosine today, which is a tool that you can use to assign and verify container images. It's by no means the only tool that exists on the market. There are a bunch of other ones like Caverno, like Notary, etc., etc. They also build like certificate authorities. So if you were trying to establish trust, you need certificates. You don't really have to produce the certificates yourself. You don't have to be all CA. You can use this publicly available CA. And the other one I'm going to touch on very quickly is Recore, which is basically a publicly accessible time-stamped transparency log. In other terms, it's a log, a ledger, in which we can store and retrieve events about the fact that a software architect have been signed and verified, right? This is the Sigstore edition of what software supply chain security could look like in the supply chain part of software issuance. As a developer, you can or you should somehow request a certificate to prove your identity. That certificate can be used to sign your artifact you're producing. Then you publish your signed artifact to a place that people will retrieve it from, and then you also write into the Record transparency log the events that have that this signature have this software have been signed, and then as end users they can find and download your artifacts. They can check your signatures in the logs, and then they can also use the root of trust to verify that the signature is coming from a legit source. So this kind of end-to-end process is one way of doing software supply chain in open source, because in open source, typically developers and end users are all working toward publicly available or publicly accessible places like the Record transparency log, the place where artifacts are stored, etc., etc. But you can take more or less the same process and try to apply it in a private setup with private logs. So we talked about Salsa. And last thing I'm going to talk about, and then I'm going to do a quick demo to just kind of illustrate the point of what software supply chain security could look like, is this thing called SBOM, or Software Bill of Material. So what Software Bill of Material, essentially, it's metadata that you add to your software, which contains things like who supplied the software, what are the components that have been used to build the software and the versions of these components, what are the dependency, how much dependency looks like, who authored the SBOM, and the timestamp for the SBOM. So an SBOM can be generated for pretty much any artifact. Most of the SBOMs today come in either two formats, SPDX or CycloneDX. If you are using something like Docker, it does have a feature to generate SBOM. I know that some companies that does like some cloud companies that does artifact storage, they started implementing features where you store something and then the SBOM is just generated automatically for you, so you don't even have to do it. I used in the past a tool called Sift, that's SYFT, and it's one tool to generate SBOMs also for container images. There are many ways to achieve the same thing. The whole point of Software Bill of Material is to be able to say, these are the dependencies that are used inside my my software, right? And add that as a metadata to your artifact. So if you put these things together, Salsa and SBOM are really complementary. If you have already a Salsa process in place, it could be actually easier to generate SBOMs because you already follow some set of best practices that makes generating SBOM just an extra step in your build system. Salsa practically is a set of practices, a set of principles. SBOM is more concrete and more implementable. I'm going to show you an example. So I'm going to just stop sharing for now the slides and switch back to my all screen. Sorry, you're going to see a bunch of so hopefully this is visible. Let's see. Okay. So what I have here is I have basically a very basic container image. So let's just download some or set some variables that I need. And I will show you in a bit, but I basically have a container image here, just a very simple Go app. that I'm going to build using Docker. So that should not take too much time, hopefully. So if I do Docker images, you can see there, it's just a very simple image. So I'm going to do two things. I'm going to tag it with two different tags, one tag that says unsigned and one tag that says signed. So I'm just tagging two container images, and then I'm pushing to a remote registry. I'm using Google Cloud here. This is how our container registry or artifact registry URL looks like. Again, this can work even with Docker Hub. It doesn't really have to be Google Cloud. The tool I'm going to demonstrate today, it works with OCI, which stands for Open Container Initiative. So essentially, any sort of OCI compliant registry, this would work. So here I have my unsigned image that I pushed. It just to demonstrate a purpose here. And then what I'm going to do is I'm going to also push my signed image, and I'm going to grab the SHA, the signature. So if I do an echo on that variable, this is my signature here. And if I go back here and double check it in 1 second, I have my signed image here, right? Like, okay, nothing too crazy. This probably is already familiar to most of you. So now, nothing. If I am using Kubernetes, which I'm going to use in this case because that's one of the products I work on, basically, if you are familiar with Kubernetes, you're probably familiar with this. If you're not, basically, I'm just deploying things to Kubernetes, create deployments called Hello World, and I give it an image. If you are familiar with Kubernetes, this basically would just work. What this is going to do, sorry, it already exists, so let me delete it. Deploy hello. Hello dash world, right? Okay, good. Boom. Okay. So if I try to check my containers, I have my hello world running. So if you are familiar with Kubernetes, you're aware that Kubernetes basically doesn't have really opinions about where images are coming. I tell Kubernetes deploy this thing. I tell it an image. As long as it can reach that image, it will just pull it and deploy it for me. This is on the surface not big problem, but it becomes a problem if you're just downloading and installing randomly downloaded packages from the internet. A much better version of this would be that I, as the developer, or I could also be the build system, so it doesn't really have to be a human being, it can be an automated system. I can establish trust by creating an artifact and signing that artifact with a key. And this is where the tool called Cosign comes into play. So Cosign is an open source tool by Sigstore, very unopinionated. It can work with pretty much any OCI compliant image. So as long as the image is OCI, Open Container Initiative compliant, it would work. And then what you use to sign the certificate or the key that you use to sign can be coming from any source. You can use the Sigstore CA to generate the certificates and use them to sign, or you could just use your own. For me, it's convenient to use the Google version of KMS, which is Key Management System. I already created a key in KMS. It's just an asymmetric crypto key. And by crypto, I mean cryptography. And I just here go cosign, sign, dash key, and then I give it the link to my key. And then this is my container image that I want to sign. So this is the container image hosted in my container registry. Here I have a --t log upload false, which basically says do not upload a signature to the transparency log. And the reason why I'm doing this is because my registry is private. So I don't want a public signature that contains metadata about my container registry. If I go here and I refresh this hello world signed image, now if I click on it, sorry, I can see here that I have basically two artifacts inside. This one is the container image itself. This one is a manifest which contains a JSON payload, which is essentially my signature, right? Very straightforward. Now, what I can do in a later stage of my build system is, remember, with sign-in, what we're doing is we're establishing trust. I can verify trust, and I can verify trust using cosign again. With cosign, I can just say verify, I give it the key, I give it the container image, and then if I run it, it will just tell me the cosign claims were validated, the signature was verified against the specific public key. So now I am quite sure that this container image have been signed by the people that have said they signed it. Now, I can go a step further, and cosign itself has a policy controller. So if you're not familiar with the concept of policy controller in Kubernetes, essentially think about it as a gatekeeper. It's a piece of software that is deployed in your Kubernetes cluster, and before it allows certain actions to happen, it would verify them against certain policies. Cosign has a policy controller which allow you to verify images against certain keys before allowing them to be deployed. So I already deployed it. I'm not going to go into the details. I don't want to bore you with the details. I already created this image policy here. This image policy, what it does basically, it says for all images, so glob star star means all images, please verify against this key, right? That's it. And then all I have to do extra is I will just, for the purpose of demonstration, I'm creating a namespace, like a clean namespace called test. I will have to label it. In order for the policy controller to work, it needs to have this label set to true. And then now, if I want to go back here to my container image for 1 second and take the unsigned image, the one that I called unsigned because I wanted to, I will take the SHA for that unsigned image, which I believe is the same, but just to make sure, I will export my SHA and I will try to deploy it. Remember, I'm deploying the unsigned image toward the test namespace. Then I will have an error that says that validation failed, blah, blah, because of this policy. That's my policy I created earlier. It's called private signed images CIP. And it basically says, blah, 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 signature key validation failed for authority for this container image, no matching signature. So because that container image that is called unsigned is not signed. Well, that's redundant, but you get the point. However, if I try to take the signed image and deploy it, this should just work, right? Because again, I'm able to verify that my image is signed. And this is just a super simple, maybe super dummy way to explain container signature in Kubernetes. Again, all of this stuff can be implemented through any other method that you wish to. Now, container or like software supply chain obviously does not only it's not only limited to how you create, sign, and share software. It because we're talking about the end-to-end way of supplying secure software, we have to also talk about how do we build it, where do we build it, where do we develop it, how do we scan that our dependencies are good, etc., etc. So we at Google have a set of products. Again, I'm not trying to like turn this into a sales pitch. I'm only going to focus on the things that I think are cool or are free. So you don't really have any obligation to use any of our tools. And again, you can use anything else. So we have come up with something called Software Delivery Shield. It's a set of products that tries to solve the end-to-end supply chain problem, starting with something called managed development environments. Sometimes they're called cloud development environments, CDEs. We are not the only ones that offer this. There is tons of other companies. You can go with the GitHub Dev. It's a very popular one. If you just do GitHub Dev, it will open a VM-based environment for you. Another one would be gitpod.io. So git as git, gitpod.io, which also does CDEs, and they are free up to a certain extent. We have something called cloud workstations. They are fully managed development environments in the cloud. Actually, I think you probably haven't realized that, but that's pretty much what I have been using. Let me just double share my screen real quick. So I basically have a development environment here in Cloud Workstations. It's just a very basic virtual machine. This one is based on Visual Code as an IDE, but Cloud Workstations support multiple other IDEs, including IntelliJ, PHP, Chorm, and a bunch of other ones. And here, of course, you can just connect to it from the console, from the web, which if I go here and click on the launch button, it will just fire up a web page, and you will see that the default, the basic editor just looks like Visual Code in the web. I personally do not like using the web. So what you can also do is you can start a tunnel, start a reverse SSH tunnel, essentially, and then you can use the SSH clients inside Visual Code. This is Visual Code deployed on my machine, on my MacBook, and connect to host, and then just connect to localhost to that tunnel. And this way, I get a full-blown heavy client just to make sure you trust me. This is actually a Linux workstation. I am on Mac. My laptop is Mac. So I'm on a fully Linux workstation. Essentially, I am on a remote workstation. I am using my Visual Code, but I'm using Visual Code as more like a client. But all my code, all my backend, all my basically software is somewhere in the cloud. Again, no obligations to use this. You can literally use any other products on the market. Doesn't matter. The point is to understand the idea. Something that we provide for free is something called Google Cloud Source Protect. So if you're using Google Cloud Code, which is a plugin in Visual Code that allows you to interact with Google Cloud, there is something called Protect in it. And the Protect essentially is a continuous scanning for your dependencies. So it works for Java and Python and a bunch of other programming languages. I don't remember. The example you see on the screen is basically looks into your pom.xml file and then continuously scan your dependencies and tell you which vulnerabilities those dependencies contain. This is completely free. Another completely free tool is assured open source software. You can ignore the artifact registry one, but assured open source software, what it is, it's basically 250 plus Java and Python packages that we download, we as in Google, we download, we scan, we fuzz test, and we provide them completely free of charge. Again, only free stuff. And with that, I'd like to thank you very much. I hope this was useful. Feel free to reach out on Twitter or X or whatever you call it these days if you have any questions. And thank you for having me.